Chemistry Video Worksheet 4. Topic: Atomic Structure. Alright, in this worksheet, you look at exam type questions. Okay, but before that, let me just revise a few additional notes. Okay, so how to tell the difference between atoms, ions, and isotopes given information of protons, neutrons, and electrons. Now first, let's look at atoms. Atoms have the same number of protons and number of electrons, okay, as they are neutral. Okay, so if you recall at the revision video, okay, I mentioned that for an atom, okay, the number of proton is equals to the number of electron, okay, and since the charge of the proton, okay, is positive 1 and the charge of electron is negative 1, okay, if they have the same number of proton and the same number of electron, it will cancel out the charge and the charge will be 0, okay, as per this example. All right, for magnesium, they have 12 proton and 12 electrons, right? Positive 12 plus negative 12, you get a 0, okay? Hence, the overall charge is neutral for an atom. Now, what about isotopes? Isotopes are the same elements that have the same number of proton but different number of neutrons, okay? So again, the revision video on isotopes, okay? This is the definition of isotopes. Right, and we have the example over here, okay, but you must bear in mind that isotopes are atoms, okay, isotopes are atoms, meaning, okay, isotopes, they have the same number of proton and number of electron, okay, as per particle, all right, same number of proton electrons, same number of proton electrons, okay. Now, how are X and Y isotopes of each other? They have the same number of proton, however, the number of neutron is different, okay. So this is the definition of isotopes. Right, moving on. What's a positive cation? Positive cations, okay, have more protons than electrons, okay. So if you look at the example from Chemistry Worksheet 2, magnesium again, right, for magnesium atom, it has 12 electrons. However, okay, when it becomes a magnesium ion, okay, achieving 2+ implies that it gives away 2 of its valence electrons. Okay, magnesium atom gives away 2 of its valence electrons and exposing the second electron shell, you will get 2 on the first shell and 8 on the second shell. Okay, 2 plus 8, you will get 10 electrons. So you compare the atoms and the ions. All right, positive ions will have more protons as compared to electrons, right? The number of protons doesn't change, however, the number of electrons decrease. Okay, so more protons than electrons. Now, what about negative ions? Negative ions have more electrons than protons. Okay, now let's look at why. Okay, from the original atom, okay, oxygen atom, all right, 8 protons, 8 electrons. However, for it to become an ion, it will gain 2 electrons, okay, because on its outermost shell, it only has 6. Okay, so you need to take 2 more to achieve a full octet structure. Number of protons remains the same. Okay, so the number of electrons is 8 plus 2, which is 10. So if you compare the number of protons and electrons, the number of electrons for a negative ion is indeed more than the number of protons. Right? Okay, now looking at question number 1, the table shows some information about 2 ions, P and Q. Okay, let's just look at the table. P has 12 protons, 20 neutrons, and 18 electrons. Okay, so we note that this question, P and Q are ions. Okay, and true enough, the number of protons for P is more than the number of electrons. Okay, so since the electron is lesser than the number of proton, okay, implying that there was a loss, okay, lose 1 electron. Okay, what kind of ions lose electron? Okay, it's actually a positive ion. All right, so P is actually positive 1 plus. Okay, this is a plus. What about Q? Q has 21 protons but 18 electrons, implying that Q has lost 3 electrons. Right, since it loses electron, it is a positive ion. Alright, and it's 3+. Okay, so what can we say about P and Q? Alright, option A, they are positive ions of different elements. Okay, different elements implies that different number of proton. Okay, so let's look at this. The number of proton is indeed different, implying that they are from different elements. Are they positive ions? Yes, they are. They are both positive ion. Okay, so A is correct. Now let's look at why the rest of the options are wrong. Okay, the rest of the option says, okay, positive ions, yes, but same element. Nope, they are not the same element because the number of proton is different. Negative ions, P and Q are positive ions, so C and D is out. So my answer for question 1 is A. Okay, moving on to question number 2. What is the atomic structure of A 2- ion in which A has an atomic number? Okay, another word for atomic number is proton number. Alright, atomic number of 8 and mass number of 18. Okay, so they want us to find what's the atomic structure. So first of all, if atom A has a proton number of 8, this implies that it has a proton number of number of electron is actually 8. Okay, remember, electrons and protons of atoms are the same. Okay, neutron is actually 18 minus 8, we get 10. Alright, this is for atom A. Now, ion A, on the other hand, we have the same number of protons, same number of neutron, but the number of electron is different. Okay, since it's a negative ion, implying that it gains 2 electrons. Alright, gains 2 electrons. 2 minus means gains 2. Alright, so 8 plus 2, I'll get 10. Okay, so they want us to find the atomic structure of this ion. I'm just going to match this to the option. Okay, number of electrons 10, proton 8, neutron 10. My answer would be D. Okay, D will be my answer for this question. Alright, moving on to question number 3. Which of the following pairs of particles have the same electronic configuration? Alright, for this question, you are required to use your periodic table. Okay, so let's look at this. Ar is argon. Alright, so Ar is an atom. Alright, if you refer to periodic table, okay, number of proton is 18. Alright, so for argon, it will be 2, 8, 8. Okay, Cl minus, okay, chlorine is 17. Alright, chlorine atom is 17. Okay, 17 protons, so it's 287. But for the ion, okay, it's 288. Okay, for Cl minus again, 288. Sulfur, this time around is an atom, so sulfur, okay, is actually, if you look at the table, alright, 16. Okay, so just going to write it down. 286. Electronic configuration is different. Okay, O2 minus. Okay, so O2 minus 8 plus 2 electrons, so it's 10. So it's 2, 8. Okay, this is the electronic configuration for oxygen ion. Alright, F is 2, 7. So electronic configuration is different. Alright, P and S, okay, phosphorus is 15. Alright, sulfur is 16. So for phosphorus atom is 285. Sulfur is 286. Alright, so again, both are different. So the answer for this question is A. Moving on to question 4, the table shows the atomic structure of 7 particles represented by letters A to G. The particles are atoms or ions. Okay, the letters are not the symbols of the elements. Alright, so we need to decide based on this information here whether they are atoms or ions. Okay, if it's ions, positive or negative. Right, so first of all, I'm going to check which of the following are atoms. Okay, because for them to be atoms, the number of electrons and the number of protons must be the same. Right, so particle A is an atom, particle B as well, particle C as well, particle D as well. Alright, particle E, 10 electrons, 13 proton. Alright, so it's an ion. Okay, it is an ion. Okay, but since the number of electrons is lesser than the number of protons, so it loses electrons. Okay, the particle that loses electrons are your positive ion. Positive ion is formed when the atom loses electron. Okay, for F, number of electrons and protons are the same, so against an atom. For G, okay, there is a gain in the number of electrons. Alright, there is a gain in the number of electrons. So an atom gains electrons to form negative ion. Alright, so this is question number 4. Okay, moving on to 4b part 1. Which two particles are ions? So based on the table, E and G are our ions. Okay, because the number of proton is not equals to the number of electrons. Okay, which particles is an atom of a noble gas? Noble gas, okay, belongs to group 0. Alright, they have full valence shell. Okay, meaning that is either 2 or 8. Alright, 2 or 8 on the outermost shell. Okay, so we're going to look at the electrons here and write down the electronic configuration. Okay, based on 8, okay, is 2, 6. 14 is 2, 8, 4. 2 is 2. 13 is 2, 8, 3. Okay, for the ions over here, I can just want to write it, it's 2, 8. Okay, for F is 2, 6. And for G again is 2, 8. Alright, we need to note that these two are ions. Alright, these two are ions. Okay, so they are not noble gas. Okay, they want you to find an atom, which is a noble gas. So C is an atom and it has a noble gas configuration, which is either 2 or 8. So I say C. Okay, part 3, which two particles are atoms and an ion of the same element? Okay, so for them to be the same element, atom and ion, the number of proton must be the same. Number of proton must be the same. Same element implies the number of proton must be the same. So looking at this, I have A and F, alright, or D and E. Alright, so which one would it be? Okay, they want me to find atom and an ion. Alright, so let's see. For A, F, what I said, although they have the same proton number of proton, okay, but they are both atom. The question wants me to find an atom and ion, so my next option would be D and E. Alright, one is an atom, one is an ion. So for this case, my answer would be D and E. Part 4. Which particle has the largest mass number? Mass number is the number of proton plus the number of neutron. Okay, so a little bit of maths down here, okay, but we would realize that 14 plus 14 gives me 28. That would be the largest mass number, okay, implying that is particle B. Which particles are isotopes of each other? Okay, so again, the definition of isotope is the same number of proton but different number of neutron. Okay, they must be atoms. Alright, same number of proton. Okay, A and F, different number of neutron. Alright, for A and F is different, but the proton is the same. So my answer is A and F. Alright, so for part C, name the subatomic particle that is involved in a chemical reaction. Okay, so when a chemical reaction happens, okay, the atom will lose or gain electrons, okay, whereas the number of proton and the number of neutron remains unchanged. So the subatomic particles that's involved in the chemical reaction would be your electrons. So what are the subatomic particles again? You have your proton, electrons, and neutrons. So electrons will be the one that's involved in a chemical reaction. Okay, so that's for 4C. Question number 5, a 3 marks open-ended question. Alright, sodium and the element of proton number 10. Alright, this we have to refer to the periodic table to find out which element has proton number 10. Alright, they have very different chemical reactivities. Alright, reactivities. Use the electronic structure to explain this difference. Okay, so we got to think, how are we going to structure these 3 marks? Okay, so I can put 1 mark, okay, to talk about the electronic structures of sodium, okay, how one valence electron would cause it to be unstable. I can have another mark to talk about what is this element with number proton 10, and use the other mark to talk about its electronic structures. Okay, so here's the answer. All right, first mark, all right, the identify what is the element with proton number 10. It's neon. All right, neon has electronic configuration of 2, 8. Okay, so this is my first mark. Since it has 8 electrons in its outermost shell, it is chemically unreactive. Okay, as it has stable noble gas configuration. Okay, so the other mark will go to the chemical reactivity of neon. Okay, by talking about the valence electrons. Okay, right. Then after that, I'll talk about sodium. Sodium has 11 electrons, so 281 will be the electronic configuration. It is chemically very reactive. Why? Okay, since the atom loses its valence electron readily, okay, so it has 1 valence electron and it loses readily to achieve stable noble gas configuration. Okay, as compared to our neon, already has 8 on its valence shell, so it has stable noble gas configuration already. Okay, so this is question number 5. Question number 6, write the ionic equation for the formation of ions in calcium chloride solution. State symbols are not required. Right, so when calcium chloride dissolves, okay, it will form its ions. Alright, so let's look at what is calcium chloride first. Calcium, okay, in its ion is Ca2 plus, chloride, okay, Cl minus. Okay, so if I were to form the chemical compound, it will be Ca2 plus, Cl1 minus. I cross it down. 1 comes down to the left side. 2 goes down to the right side. So 1 of calcium. 2 of chlorine. CaCl2. So we start off with CaCl2. It will dissolve to its ions. Okay, so about the ions, Ca2 plus Cl minus. Now let's balance this. 1 calcium, 2 chlorine. Alright, so for chloride, I need to put a 2. And hence it's balanced. So this will be the ionic equation for the formation of ions in calcium chloride solution. Question number 7. The diagram shows the nuclide of 2 isotopes. Nuclide is the plural form of the word nucleus. Alright, so isotopes implies that they are atoms, okay, with the same number of protons, alright, different number of neutrons. Okay, another question is what are found in the nucleus. Okay, so in the nucleus there are proton and there are neutrons. Okay, this can be found in the nucleus. So let's look at the subatomic particles inside. There's a black colored circle and a white colored circle, but we do not know which one is the proton, which one is the neutron. Okay, however, I do know that since they are isotopes, the number of protons must be the same. So I'm going to count. Alright. For the left nucleus, the number of black particles will be 1, 2, 3, 4, 5. For the white ones will be 1, 2, 3, 4, 5. Okay. For the right one, alright, the black circles, there's a total of 6 of them. Right, for the white, there's a total of 5 of them. Okay, so clearly the subatomic particles, the black circles are different, but the white ones are the same. Okay, so what is the name of the black colored circle? Alright, that would be your neutron, since it must be different for isotopes. And white would be proton, since it must be the same. Alright, what is the relative charge of neutron? Neutron is neutral, the charge is 0, but for proton is positive 1. Okay, B part 1, draw the electronic structure of the atom, element E. So we take note that we must use E for our symbol, okay, and not the actual one from the periodic table. We do not need to show the composition of the nucleus, right? So just the electronic structure. So looking at the number of protons, it has 5 protons. All right, E has 5 protons. Since it's an isotope, it's an atom, implying that it has 5 electrons. So I'm going to draw the electron structure. 5 electrons means 2, 3. 2 on the inside, 3 on the outside. All right, so element E, 2 on the inside, 3 on the outside. Alright, you can use a dot, no problem with that. Okay, so this will be the electronic structure of element E. Atom E, alright. Identify this element E. I can use the periodic table, alright, since it has 5 protons. The element with 5 protons is boron. Okay, so element E is boron. Right, and that's all for chemistry video worksheet number 4.